Kyle worked as our designer, Holly as our assembler/presenter, Danny as our manager, and Andrew as our video editor. 790 million people in the world still don't have access to clean drinking water. One of the ways people have tried to solve this problem is by building wells in developing countries. The problem then becomes the transportation of water from wells back to the communities. The vessels people use are made from materials already on hand, which are heavy and can pollute the clean water, making it once again unsafe to drink. The goal of the Fabric Bucket Challenge is to create a lightweight, biodegradable vessel to carry 1 gallon of water for at least a minute.
For the research for our project, we found 2 main ways to waterproof fabrics. The first way is laminating the fabric. Laminated fabrics have 2 layers, 1 fabric and 1 adhesive. Different methods of coating just include wax coatings or paint coatings or anything else to try to waterproof the fabric, including spray-on silicone coatings.
For the design of the bucket, we went with a drawstring backpack style bucket. This style ensured that the water was held in the bucket and would be portable, and it would also help get some score multipliers. We were fortunate to be able to use the Craft Center sewing machines to make our project. Before building the actual prototype, we made a mock-up. This mock-up allowed us to figure out any sewing issues without damaging the materials we planned on using for the final project. For our first prototype, we started by cutting out the fabric we needed. Then we began ironing on the laminate. We also tested laminated fabric to make sure it was in fact waterproof. We used 2 layers of nylon, a canvas base, cotton straps, and iron-on laminate for our first prototype. This version was sewn as a cylinder with a base made of 2 layers of nylon that sandwiched a canvas layer between them. The body of the bucket was made of 2 nylon layers, with the inner layer having the iron-on laminate. Cotton fabric was used to make the straps and drawstring sleeve. Our 3 fabric types also worked as a score multiplier. Unfortunately, Bucket 1 had some problems. While the fabric was waterproof, water leaked through the seams in the base. The bucket only held 1/3 of a gallon. Also, we made the body of the bucket too big with the handle attached, so it didn't meet the requirements of the challenge. We had limited laminating resources, so we decided to make a new bucket to counteract the seam problem in Bucket 1. Bucket 2 was made to be smaller, and had a different design. Instead of a cylinder shape, we used 1 square of our nylon canvas layer as the base, so there would be no base seams. The base was long enough for the seam to be above the gallon water level. As an extra effort to prevent leaking, instead of using a straight seam, we used a rolled seam which hid the seam from the water in the fabric. The top of the bag was cylinder shape, with a drawstring, handle, and cotton straps. We also ironed on laminate on the inside of Bucket 2, but the laminate bubbled up in places where it overlapped or was folded, which allowed the water to leak through. To fix this, we had several options. First, we turned the bucket inside out so that the laminate part was now on the outside. It made the bucket stronger. We sprayed 8 coats of silicone spray on the fabric on the inside. The spray wouldn't have worked on the laminated part. We also coated the seams with seam sealant, which basically filled any hole made by the thread with glue. We also used clear nail polish to waterproof the places where the laminate had bubbled up.
The bags were tested by first being weighed without water, then placed on a hook above a tub of water. Then a gallon of water was added to the bag by its creators at whatever pace they wanted. As soon as the bag started to leak, the team was disqualified. If it held 1 gallon for a minute, water was added until the bag started to leak. Along with the majority of teams, our bag leaked before hitting the 1 gallon mark. This wasn't to say we weren't successful. We were. Our team won an honorable mention award, and we were approached by some teachers and professionals who complimented our team specifically on our work and design process.
just some advice for future FED groups. 1 and 2, meet often and communicate. You're not going to be able to get your project done if you don't talk to each other and say, hey, I got this, or can you do that for me? Next one is, how can I fix this? So have a positive attitude. If something goes wrong, don't just give up on it. Keep pursuing it and try and be able to correct what is going wrong. Nail down a plan or a design, but be open to change. If it doesn't work or there's a better one, I advise you to go for that one. My group tried several different designs for our project, and we finally figured out which one works best for us. Lastly, score multipliers. You want to be going for those because those will allow you to compete with the other teams and possibly even get a placement at the design day.